Today's talk is on Docker image lifecycles implemented on Jenkins pipelines. First of all, who am I? My name is Mark Galpin. I'm a senior solution architect with JFrog. So people might ask, what does a senior solution architect do at JFrog? A senior solution architect does pretty much anything JFrog needs doing that involves working with the outside world. So that tends to be a lot of coordination with our customers and with communities like this one, and with our partners. And on the other hand, a lot of coordination with our R&D branch, and of course the marketing people who pay for these wonderful conference visits and things like that. Perhaps most interesting to hear, one of the most fun things I get to do is talk to customers about CI architectures they're interested in and develop reference architectures to achieve those goals. And today we're going to present one of those architectures related to Docker. So here in the Jenkins community, a lot of you probably have heard of JFrog, but for those of you who haven't, JFrog was founded in Israel. We now have an office in the United States, which is much, much bigger than that. I need to get a newer picture than that these days, and an office in France. And if you've been by our booth lately, you've probably noticed we're a bit obsessed with frogs. And you can come visit our booth. Wonderful people there to give you out t-shirts and frogs and talk to you about our products. We have 4 products. The first product that we've been bringing to this community for many years is JFrog Artifactory, a universal binary repository. We also have JFrog bin tray, which is for binary distribution, and mission control for managing worldwide architectures, and JFrog X-ray for getting deep insight and impact analysis of concerns on binary containerization graphs. And today in this talk, I'm actually going to be talking about 3 of these products and showing you how to integrate them with Jenkins, at least a little bit, and how they relate to CI workflows. For those who are curious as well, for a little bit more about JFrog, we offer what we call our Amphibian model. Probably most people would call it a hybrid model, where we offer both on-prem and SaaS solutions for binary management and hosting, with over 3,000 customers today. But enough about JFrog. You probably want to hear about Jenkins and Docker containers, which isn't unreasonable because containers are pretty much everywhere. Every conference I go, I'm hearing about containers, and everybody wants to use them. And of course, we all want to use our favorite automation tool, Jenkins, in conjunction with our container architectures. So, first of all, a quick poll. If you would raise your hands and then, I guess, lower them as it no longer applies to you. So how many of you have heard of Docker? How many of you can do the Docker tutorial? How many of you have done a proof of concept or played with it at your company? How many of you are using Docker in production? And notice how many hands went down when I asked that question. A lot of you still are, which is really amazing, and that's really cool. But for those of you who aren't, why not? And there's a number of reasons, and I'm not going to get into all of them, but I am going to talk about one specific one, which is, I think a lot of people are in a situation where they love Docker, they love the acceleration it can bring to DevOps, but they're not entirely sure how to trust their Docker images in production. And this is something that, being able to trust your binaries in production is something that JFrog has thought about for a very, very long time. Not necessarily specifically in relation to Docker, but we've got decades of experience in managing binaries. And we've been doing Docker registries since before there was a private Docker registry offered by any other company. including Docker themselves. We've had private images, for a very long time now. But the big thing that we do that's special to this talk is, we have good ways to develop promotion pipelines in Docker. So there's a classic question that gets asked. It's not even really worth asking you to raise your hands. Who's using Docker and nothing else? And of course, that's the other side of it. If you're going to do a good pipeline and traceability of Docker containers, you also have to be tracing what's happening inside the Docker container. And the final note is, why does this matter? And probably this isn't a forum where we have to talk a lot about why this matters. But it's a valid point that today DevOps lifecycles are something that impacts everybody in the world, every single company in the world. Before I came to JFrog, I was, of course, a consumer of DevOps tools. But it's really hard to imagine until you're actually at a company offering tools and looking at just how broad the range of industries represented by your customer list is. It's really hard to imagine just how true it is when people say, what many people would tend to consider a fairly trite phrase, that every company is a software company. I can look at the customer list. I build tools for DevOps. If you're not caring about software development processes, you're probably not buying JFrog's products. And I can tell you that the range of industries that buy JFrog's products, if there's an industry out there, somebody from that industry is buying a JFrog product. And that really means everybody in the world cares about this stuff. So, moving on to the actual point, how do we actually develop a lifecycle for Docker containers? So, I'm an architect. And the first question I have been trained to ask when I'm asked this question of how do I develop a process for X, do we have an existing pattern? Do we need to adapt it? So what do we know? So I kind of started along the idea that Docker containers were VMs. And what were the patterns for VMs? And so kind of there's the traditional pattern for managing VMs that I've used in many previous jobs, where you package a server base image, you provision that instance, and then you've got Chef or Puppet or even Jenkins going out and making changes to that server as we make configuration changes. Change it. Eventually, it stops working, and I repeat the cycle again to form a new base image. Lots of people have thought about this, decided that for a lot of scenarios it doesn't really work. So you have the immutable server pattern, which says you package up a server image, you provision that instance, and you throw it away without changing it. If you want to change it, you create an entire new image from scratch. Infrastructure is code. We all agree, probably, that that's a good thing. And Docker really makes it easy. Obviously, this is the pattern that you're going to be using with Docker, because the other pattern is actually quite hard to execute in Docker. It's not impossible. We've done it. But the reality is Docker is made out of the box for this immutable server pattern. But that didn't really get me to a lot about the life cycles. This told me a little bit about what the end result was supposed to look like. But it didn't tell me a lot about how to get there. So then I thought about asking a different question. Is a Docker container more like a Debian package or more like a WAR file? Or other types of binaries. Actually, originally I had like a list of like 6 different types of binary packages and what was the closest to Docker like. And so a Debian package is like many other installers, right? It contains an app I'm installing and a declaration of the dependencies I'm going to resolve. A WAR archive, on the other hand, has the app I'm installing, but all of the dependencies for that WAR file are typically wrapped up inside the WAR file. And in fact, this is what Docker is. Well, this is the Jenkins community. This is Jenkins world. I think we all know a little bit about how to do Java WAR pipelines. suddenly this becomes something a little bit mysterious to something we've been doing for a very long time. And the pattern's pretty basic, right? I build at my machine, then I build in CI, and then I promote the binaries from my image as they go through test, and I deploy them to production after they've passed all the quality gates to get to production. And JFrog has been doing this as well. The developer writes with his build tool. From the desk, the build tool goes out to Artifactory. If Artifactory doesn't have the package, it can go out and get it. The developer finishes his builds, commits his feature branch. Jenkins picks it up. Jenkins does a build using the same tools as everybody else, but in a controlled environment. It again resolves from Artifactory. It deploys those results of the build to Artifactory with a bill of materials. And I feel obliged to point out here that up until 2 weeks from now, we didn't actually have a good way to capture a bill of materials for Docker containers. So I am going to be showing you that capability. One of the things I'm here to do is to announce that the Jenkins Artifactory plugin will be supporting Docker containers with the pipeline DSL. And I will be showing you the snapshot build of that, and it's coming out at the end of September. And then you go through the QA process. Lots of great people out here on the floor at Jenkins World talking about QA. You also have JFrog X-Ray, which can go out and test for security concerns or IP concerns or other things from internal databases about binaries that may represent concerns if they're present in your package. And when you're done, you can deploy out to your production servers with all the great automation tools for doing that, or distribute out to the world on JFrog bin tray. This is the basic process. If you've been to JFrog talks before, you've probably heard this process before. We tend to talk about it a fair amount. It's not terribly surprising. But what does it actually look like with Docker? So first of all, we have Docker build. And Docker build is really cool because it's really easy. But that can lead to a dangerous temptation to build everything with Docker build. In each environment, my developer, when he does a Docker build, he's going to do a Docker build. And then the CI server does a Docker build. And then when I deploy to test, I do a Docker build. And when I deploy to production, I do a Docker build. And there are advantages to this. In fact, it's probably faster than building a pre-built image and pulling it, in many cases. Docker images can get fairly large. And if you have to pull them down, that is time you have to pay. And it's easy. But you know what? When you're building things, fast and cheap is not always the right choice. Ask the people in China who are building this apartment building. So what do we mean by that? Well, the whole reason we have CI is to reproduce builds. But if you look at a Docker file, pretty much everything in your typical Docker file says, go out and get me the latest version of this binary and put it into this Docker container, starting with the very first from statement saying, go out and get me the latest version of Ubuntu as a base layer. Now, of course, I could fix that by going in and doing things like, for example, putting in the actual commit hash of the Ubuntu I'm going for. But at some level, I'm then throwing away one of the great advantages of Docker. That ability to update the base layer is critical because then I'm getting the latest security fixes, which for something like a Docker container, I care about. On the other hand, I really, really don't want this, right? I don't want a scenario where I saw one thing in dev, a different image in test, and a different image in prod. I don't know about you, but before I was at JFrog, I was with the Army. I saw more than one situation where we'd go out to the field, get a whole bunch of security fixes, which were, rushed out. You have to install the security fix, and all my servers crashed. Most of the time, of course, that doesn't happen. We've gotten a lot better as an industry of making sure that security fixes don't go out and break running services, both on the side of writing software in ways that are more robust, and from the people doing security fixes, doing them in ways that are a little bit more subtle. But it still happens. And nobody sane is going to want to put a binary in production that isn't actually identical to what they tested. You don't always need to use build promotion, but when you're doing it, it's got to be immutable and stable binaries. And Docker containers really are just standard binaries. And again, the model is well known. You build it once, and then you promote the pre-built binaries. Yes, you do pay a little bit more to transfer those Docker images, but you gain it all back in trust. And trust is really what matters to the people that actually have to worry about things like uptime of your services. So let's design this. What is this actually going to look like? So first of all, let's think about Docker containers. Sometimes we talk about a Docker container like it's one big monolithic object. But in reality, that's not really true. Docker containers have layers. And so the Docker container I'm going to show you for this pipeline can be divided up into 3 sections. These aren't purely the actual layers of the Docker container, but they are the layers of how that Docker container was built up. So at the bottom, I have Ubuntu, pretty standard base layer that I'm pulling. Above that, I have what I'm going to call the framework layer. So many customers, they have a scenario where they're building a number of different applications on top of some sort of base framework. In my particular case, I'm developing a war-based application. It's going to deploy on top of Java and Tomcat. And so I kind of have this base section of the Docker container that has Java and Tomcat. And then on top of that, I have my actual application, my war file. So when I'm building this, I have this war file. I want to be testing it. I want to ensure that before I say it's good to go, it's been deployed in a container and tested in that container. But it's also critical that the framework be known good. As I said, one of the cool things about Docker is that ability to quickly rebaseline the image for new security updates underneath. And I don't want to throw that away. I want to be able to have a known good framework that still can update regularly and have me trust it. But I also want to be able to do these things independently. I don't really want my development team to be worrying too much about monitoring the framework updates based on OS updates, security updates. I want them to be focusing on developing their app and doing it. And I don't want the app to be dependent on the latest framework build being smooth and working correctly. So, pipelines. I'm actually going to talk about this as 3 pipelines. If I wasn't using a snapshot build, it could actually be consolidated down to 2. But right now, I have 3 pipelines. The first one is the pipeline that builds my war file, a Gradle build. The second one is a pipeline that builds that framework layers. It takes Ubuntu, it adds Java and Tomcat, and it tests. Says, hey, is this new version of Java, this new version of Tomcat, this new version of Ubuntu, is everything still working the way I expect it to be? And of course, the final pipeline actually develops my system. So before we get too deep into my Jenkins pipelines, a quick note on my Artifactory structure for setting up Docker. I have 2 virtual repositories that are configured. The first is Docker Dev, and it has a deployment target of Docker dev local. It resolves from Docker dev local. It resolves from Docker Hub remote. And I also have, and it also resolves from Docker prod. And then the Docker prod is a virtual repository which at the moment contains just Docker prod local. And the main point of this is that my devs, my CI starting points, they all do everything through Docker dev. And Jenkins promotes all objects that get into Docker prod. The only way to get into Docker prod is a promotion run by Jenkins from Docker dev to Docker prod. And my consumers, my production systems, they only see the Docker prod repository. So they don't get to see any image which hasn't been promoted, hasn't been through my Jenkins testing process, been promoted. Docker prod is a complete curated repository. And note, they also don't have access to Docker Hub. Only curated, approved images are getting into this Docker prod virtual. It looks a little bit like this. Two repositories, 3 in Docker dev, 2 in Docker prod. Another repository I'm going to be using, at the end of this, I am going to be distributing out my products to bin tray. And so I've been using one of our other new features of Artifactory, distribution repositories. And so I set up a distribution repository. This allows me to have a rule-based approach to when I promote to the distribution repository, pushes that out to bin tray automatically so that my customers anywhere in the world can download it with a fast CDN. So, pipelines themselves. So, the Gradle build at this point is actually not yet in Jenkins pipeline. I mentioned I was using a snapshot image to bring in the Docker. The downside of that snapshot is that I could pick the feature branch that had all of the cool new Gradle stuff or the feature branch that had all the cool new Docker stuff. They say they're merging it next week. Doesn't really help me for today's talk. So I figured Gradle is something we all know how to do Gradle builds. So I just went with the traditional Gradle build, as we've been doing for years. But more interestingly are these two frameworks. So I have my Docker framework build, which is going to resolve images, do a Docker build, test it, promote. And I have my Docker app build, which resolves artifacts, builds them, deploys it, tests it, promotes it, and distributes it. Two independent pipelines that are interconnected. So, let's look at Docker framework. So, I mentioned that one of the great things about the framework is you can do some security testing. So, I had been doing, you can see I had this successful build of the framework. I can go out and jump to it in Artifactory and look at its build information. I can see it's got published modules. I can see its dependencies here. And that it was depending on JDK 891 and Tomcat 8032. And then I can see as well that it created this Docker image, and some of the layers came from a previous image. Now, X-Ray, if you saw my demo yesterday, well, if the demo hadn't had a network issue, you would have seen that there's actually an issue with Tomcats before 854, where they're recommending people upgrade. And also, I had some concerns about some older versions of Wicket, some performance issues with some of the older versions of Wicket that Tomcat was using. So I decided that I wanted to upgrade my Tomcat version. And so I went into Artifactory, and I put a new version of Tomcat in my Tomcat repository, 8.5.5. And I ran my build. And the build failed. Builds sometimes fail. Maybe you don't have this problem. Maybe all of your builds work every time. You're one of those lucky people. Personally, when I write builds, builds fail. So we want to go in, we want to investigate what happened. Let's go look at our console output. So I'm going through, I'm checking out my, my Docker scripts. Everything's good so far. Let's make this just a little bit larger so you can see it better. I am pulling down Tomcat. I can see that it pulled down Tomcat 8.5.5 just like I expected. So far, so good. I can see that in my workspace, I've got my JDK 8. I've got my Tomcat. So far, so good. And then I do my Docker build. Sending all the context to Docker. Running. And oops. In my Docker file, I had actually managed to reference that Tomcat 8.0 star. And of course, I moved to Tomcat 8.5. My build failed. So build again. I went in, went in, fixed the Docker file, built again. And you can see that this next build was green. Because now instead of going for 8.0 star, I did 8.star. Solved that problem pretty handily. I deployed the build out to Artifactory. I pushed it. I retagged it as latest. Then I'm going out and actually on a separate node here, I'm running the tests. And the reason, it would have been easier just from the script perspective, of course, it would have been easier not to do it on a separate node. But pipelines have this really cool capability where you can parallelize nodes, run on multiple slaves at once. So this could do if I wanted to test, say, on a Linux slave and a Windows slave, I could have been doing that. Or if I just had a whole bunch of tests I wanted to run in parallel, I would have been using this capability. So in this case, I re-pull the Docker image, and then I run it. And but actually, before I run it, I build it again. And what I'm doing here when I build it is I am seeking out the last war file that has been promoted to release. So in this particular case, since I had just run a build before, I hadn't released a new version of the war file, so it didn't really have to download very much. You can see it didn't actually download anything because it was already in the workspace. But it went out there and it said, hey, I've detected from a latest version call in Artifactory. I asked Artifactory, what is the latest version of the war file that has been promoted to a release status, which means that it's been through all of the tests in the pipeline, been distributed. I'm sure it's a known good war file. And I pulled it down. And then we used that to build. And then we did a quick test. Can I curl out the web page that this war file serves? The answer was yes. And so then we promote the framework and say, OK, this framework is known good. I've tested it against the last version of the war I know worked. It's still working. So upgrading the version of Tomcat did not break my system. So I can now drop this into production. And the Jenkins file for this looks a little bit like this. And all of this stuff is out on our GitHub. on JFrog training Docker Lifecycle scripts on GitHub. Feel free to check it out if you want to see the Jenkins files that, that I'm using here today. And some quick things I just want to point out. I showed a little bit earlier. We've got these resolver specs. I set a download spec that gives some sort of pattern for what I want to download. In these cases, I'm going for a very specific version of the JDK and going for the latest version of Tomcat, as I've detected from somewhere else. There's a lot of other options. For those of you familiar with Artifactory query language, the pipeline DSL allows you to actually download artifacts based on an Artifactory query language query now. Way too many features of the pipeline DSL to show them all today. And then I just say I want to download it, and I want to allocate it into the build info, and I generate the build info. And when I do the Docker build, I say, I do a standard Docker build, and then when I push it, I say I want to push this tag. I give the repository that it's pushing to, and say attach it to this build info, and then I say publish the build info. And then I'm using an internal Artifactory API to retag that pushed image to also be the latest image. So then the other big pipeline is the app pipeline. And while that's running, I just want to show one final thing about this. Got 855 builds used by 2 builds of the Docker framework. I go out to that build, and I can actually diff and see from 23, I can see my top layers started to change from build 23 on the old version of Tomcat. And I can see that that was because my Tomcat 8 dependency that Docker was using changed, as well as see all the environment variables that changed. So this is the app build. So the app build starts by going out and getting the latest version of the war file. I had built a new version of the war ahead of time, so you can see it downloading the war file from Artifactory. And it sticks the war file in Tomcat. And then it deploys the build info. So I can now see build 29, nice two-way link back between the 2 builds. I can see the published modules. There's my war file that I actually used. And there's my Docker image. And I can see on this one, most of the layers are actually from the from image, and only the couple at top are not. And we look at the console output. So it goes out and it does that. Now, the big thing here is that the Docker file that I'm using here is pulling from Docker prod when it gets the framework build. In my test section, when I was doing this, it was pulling from Docker dev when I ran my test. And really, that plus the new war file are the differences, right? So I'm going with a known good Docker framework and a known good test. And then to test it, I just run the image. And when I'm satisfied it's good, I go out and I promote my Docker image, and I promote my war file. I go out and get its properties to know what build the war file came from. And then, after I promoted the war file, I go out and I do a distribution out to bin tray of my artifacts. You will see some error messages here. This is a snapshot build. Everything did distribute correctly. but the way we distribute Docker images, it needs to know that when we do a build promote of Docker images, there's a piece of logic we have to add in. But it did, in fact, distribute correctly. These error messages actually don't represent an actual mistake. And now if I look at this again at the release history, it can say, hey, this one is now in Docker prod because it passed test, which matches the fact that everything is green here. And if I go out to bin tray, I can go out to my product pipeline demo, and I can see both the various Maven packages that go with it, as well as the Docker registry. So they're end-to-end. I've shown with the Docker pipeline, I've created a distributable Docker image. And at no time, have we ever been in a scenario where we actually broke the set. And when I was doing some of this prep earlier, I actually went out and did this, right? You saw the build history there. I went out, I changed the Tomcat version, I tested it. That was completely independent of changes to the WAR file. Had complete trust that no matter where I was in the pipeline, it was safe. So I've kind of walked through these pipelines, but this is what they all look like. This was the application pipeline. This is what the whole thing looks like. Oh. This is what the whole thing looks like end to end. The three pipelines with the different colors. It's a fairly complex scenario, but really only complex in the code. Conceptually, it's a fairly simple concept, right? I have my underlying infrastructure. I'm testing that against known good versions of my application. And once I've got a new approved underlying infrastructure, I can use that in the builds when I'm developing new versions of the application and push that out. It's all about automated testing and automation in general. So you might ask, of course, this is a live demo. Of course, I picked a happy path. Are there ways that these pipelines can get frozen? I'm only aware of one scenario that can freeze up this pipeline and this pattern. And the only scenario that can freeze up this pattern is if there is a security fix at the infrastructure layer that requires a non-backwards compatible change to the WAR file. This doesn't happen very often anymore. I can remember times when you did a security fix and it required that everybody switch to a new API. This doesn't tend to happen a whole lot anymore, but it could still happen. But usually, what you have to do is you have to switch to a different API that's been there all along, and it will still work on the old version of the infrastructure, so you just prime the pipe and move forward. In terms of triggering these builds, typically you trigger on two scenarios. You trigger when your Git repository changes for the WAR file, or when you have new versions of stuff. When you do a new framework build, you may want to trigger the app build, the app pipeline. I actually didn't put that trigger in. I just did Git triggers. Because my theory there is that in general, the app is being iterated rapidly enough that new framework builds are just going to get pulled in automatically as you're iterating the app. But if you're going with a slightly slower development cycle, you'll probably want to iterate on either scenario. So the question is, did we do it? Does this pattern meet the goals? And I think it does. In a moment, I'm going to let you give feedback and ask questions, and maybe you have a different opinion. If so, feel free to do it. But the big question to say this is, can I trust that I have a scenario where I've always tested the system before it gets into prod? And the answer is yes. Do I have a system that allows me to quickly adapt to security updates in my infrastructure? And the answer to that is yes as well. So I really feel like yes, this is a pattern that works for bringing Docker into production. Automate everything, release fast, modular builds. It's the right way to go, and it is what JFrog as a company is dedicated to helping you do. Okay, well, I am out of time. If you have more questions, I'll be up front for a minute or two, but also you can drop by our booth. I will be at the booth for the rest of the day and more than happy to answer any questions you may have. Thank you very much for your time.